Oxidation and reduction. It's a reaction where electrons, notice that word, electrons are transferred from a compound or element, a substance, to another. So the key word here is electrons, You've seen atoms being transferred in single replacement, double replacement, or even with acids and bases, but with oxidation reduction, it's electrons that are being transferred. Also called redox or redox reactions, that we just usually in chemistry call it redox reaction. It's a very, very important topic. You may think of it as just strictly a chemistry topic, but it's incredibly, incredibly relevant to everything you can think of. So I'm going to show you an example of each, before we begin discussing the nature of these reactions. Right here. So this is the Golden Gate Bridge. You have this maintenance construction worker. I'm not sure what you refer to them, but this person is high up, very, very dangerous job, high altitude, helping to maintain the Golden Gate Bridge by painting it using all kinds of chemical materials to protect this amazing, amazing structure, the Golden Gate Bridge in San Francisco, from deteriorating. What's causing deterioration? Well, it's oxidation reduction. Oxidation is the other name for rusting. It's a process that is devastating to infrastructure, but we have to maintain it. So if there was no oxidation reduction, there would be pretty much not that much maintaining you have to do. But think again, because this is a process that is important in life. So you have ADP, ATP. You might have heard about these in biology class, but it's called an oxidative phosphorylation. So there you go. What is happening? Well, when ATP, adenosine triphosphate, breaks into ADP, which is adenosine diphosphate, it's undergoing an oxidation reduction reaction where it's releasing electrons. So you see here what they call electron carriers. So this process of losing and gaining electrons, we will define shortly, enables the cell and the mitochondria to produce energy and power your cells. And finally, we have the process of gold electroplating as an example, or chrome plating. This is a process that, as you are familiar with it, simply slaps on a, very, very tiny amount of gold on a much, much cheaper metal, such as brass, nickel, etc. And this process is achieved by oxidation reduction. You will learn about it in terms of electrochemical cells in general chemistry too. Very, very important. So let's go back and learn about the process. So oxidation and reduction can be really symbolized by using a very, very simple reaction. This is table salt. Table salt is made by taking sodium as an element. So as an element has its own number of electrons, and you have chlorine also as an element. And you're making a compound. But before we go there, notice how sodium is in the elemental form. These are sodium atoms packed together as a metal, and this is chlorine. It's a diatomic, remember, element. And what happens is that via oxidation reduction, they produce table salt. And if you notice here, you see charges, plus and minus. So plus and minus should indicate to you that something lost electrons and something gained electrons. And we learned about that. So again, here you're ending with a compound, but it doesn't have to be even a compound, and it's a plus or a minus. You have charges right here. So let's learn about this. What is oxidation? Before we begin, knowing the definitions is very, very important. A lot of the problems encountered in this topic is students forget the definitions, these simple definitions. So oxidation is the loss of electrons. So when an atom, ion, or molecule has lost electrons, we say it's been oxidized. So the verb is oxidize. When you say something has been oxidized, meaning it lost electrons. One way of remembering it is if you remember this acronym, OIL. So OIL is oxidation is loss. So of course, and we mean loss of electrons. So oil right here. Let's look at it. We'll take these two sodium atoms. These two sodium atoms, when they lose an electron each, we show it this way, they become sodium ions. Those are the ones you used in naming. Notice the plus charge, a plus charge. So if each lost an electron, that means we have two electrons right here that came out. Let's just ignore the apostrophe here for just the sake of clarity here. So that's two electrons. So they were lost. They came out on the other side. So this is oxidation. We say sodium has been oxidized and again, lost two electrons. So keep an eye on those electrons. Reduction is the gain of electrons. Let's say gain of electrons. And that acronym is RIG, oil rig. So rig, if you know what an oil rig is, it's that structure that is used in oil fields to extract the oil and petroleum from underground. It's called an oil rig. You would know that reduction is gain. Of course, we mean electrons. So R-I-G, oil rig, oil rig. So we take that Cl2, and now notice that one lost, so the other must gain. So those same two electrons, you add them to the chlorine, and you have two atoms, they become 2Cl minus. 2Cl minus. Now, it's important to show you this, that these same electrons right here, that chlorine gained came from sodium. They didn't come from nowhere. Of course, that's impossible in chemistry or physics. It's a law of conservation of mass. So these were lost, these were gained. So we say here that, of course, this one gained 2 electrons. So here you go. You have your oxidation reduction processes. Two important rules to remember is that oxidation reduction occur together. When one substance loses electrons, another substance must gain them. So you cannot just say that all of a sudden these electrons are floating around doing nothing. No, that doesn't happen. Electrons have to have a carrier, have to go to another element. unless of course you're talking about electricity, etc., or in the sun where we have plasma, but that's not the case in the chemistry that we're dealing with. So again, they must occur together, And the number two is what we just talked about, is that number of electrons in the reaction does not change. You cannot simply say I have 2 electrons lost by sodium and then show me 6 electrons gained by chlorine. So where did those electrons come from? Matter does not, again, disappear. So, or mass doesn't disappear, so nor appear. So that's the idea, is keep these two rules in mind. Think about this, and then in the next video, we'll learn about the basics of oxidation reduction, which is oxidation numbers.